Hey everyone, welcome back, and today let's solve Leetcode problem 2873 titled Maximum Value of an Ordered Triplet. So we're given a zero index integer array nums, and we want to return the maximum value over all the triplets of indices I, j, and k, such that I is going to be less than j, which is less than k, and if all such triplets have a negative value, we simply want to return 0. Now the value of a triplet of indices I, j, k is equal to nums at I minus nums at j, and that difference being multiplied by nums at k. So in example 1, we have our input array nums to be 12, 6, 1, 2, 7, and in this case, the maximum value of a triplet of indices I, j, and k would be 7, meaning the first two elements in that triplet of indices being kind of subtracted from each other and taking that difference and multiplying it by the third element nums at that index k. In this case, the reason why that output is going to be a maximum value of 77 is because we can take the index 0, we can take index 2, and we can take index 4. Right? If we take those corresponding indices, we get 12 minus 1. That's being multiplied by 77. The difference between 12 and 1 is 11, and 11 times 7 is 77, and there are no other ordered triplets in this input array nums in that order of I, j, and k that have a value greater than that output of 77. In example 2, we have our input array nums to be the following, and in this case, the reason why we have an output of 133 in this case is taking the values or elements at indices 1, 2, and 4. If we do that, we get 10 minus 3 is 7. 7 times 19 would be 133, and our I, j, and k values or indices would be 1, 2, and 4. And nums at I, j, and k would be 10, 3, and 19, giving us that formula and giving us that maximum output. And there is no greater pair of indices that has a greater value than 133. Finally, in example 3, we have 1, 2, 3. In this case, we only have one ordered triplet. That would be 0, 1, and 2 for our indices. That would give us a value of 1 minus 2 times 3, which is negative 1 times 3, which is actually a negative 3. It's a negative value, and we're actually told in the problem statement that if all triplets have a negative value in the input array nums, we want to have an output of 0, and so that's why we have an output of 0, because of course 0 is still greater than any negative value. So for the constraints here, we see that the input array nums is going to have a length between 3 and 100, which is quite small for input constraints, kind of telling us that we don't need to have the most efficient solutions. I do believe triple loops would nested loops, triple loops would actually work, although it wouldn't be that efficient, and any value in the input array nums would be between 1 and 10 to the 6th power, which brings us to the main observation that we really need to make to solve this problem in the most efficient manner, not big O of n cubed. And that is that we really have three different kind of factors or elements to worry about, right? Notice how, again, the value of any triplets of indices in our input array nums is going to be the difference between the first two elements in that pair, and that's in that triplet rather, and that's going to be multiplied by nums at k. To maximize the value of all triplets that we can potentially make, we want to maximize our nums at I value, we want to minimize our nums at j value, and we want to maximize our nums at k value. Why do we want to do that? Well, first of all, when we're taking a value and subtracting it from another value to keep our result as big as possible, we always want to minimize the number of things or the value that we're subtracting of. If we have 12 as nums at I, we don't want to subtract 10 as nums at j. That's just too large. We'd rather have 12 minus 3, or even better, 12 minus 2. The smaller the value that we subtract, the higher our value is going to be. And any value being multiplied by a larger amount is going to give us a larger result. And so we always want to have the largest difference being multiplied by the largest nums at k value to get the largest value. Hence the reason why we want to minimize the actual value that we're subtracting from nums at I from, to get the largest difference at nums at I minus nums at j, and always maximize nums at k, because anything that's larger relatively being multiplied by another very large amount is going to give us that larger and larger result. And so we want to, again, maximize nums at I and nums at k, and minimize the value that we're subtracting from nums at I, which would be nums at j, and so that's what we want to minimize. So with that out of the way, let's go ahead and kind of get that idea out in our actual code. So we're going to, again, keep track of three things, right? We're going to have the maximum kind of prefix, if you will. That's just basically the maximum value. We're going to have the maximum difference because, of course, we want nums at I minus nums at j to have the largest value possible because we want to maximize our value. And we also want nums at k to be as large as possible as well. We're also going to have a maximum value that's going to hold the actual maximum triplet value that we find throughout all indices or iterations of our input array nums, which is effectively what we're going to return as our output. So let's go ahead and get to the code here. So I'm going to actually initialize my max value. to be 0, and all of these, of course, are going to be initialized to 0. My maximum difference, again, the maximum difference is nothing but the difference between nums I and nums j. That's what we're trying to, again, maximize to multiply that by nums k, which is also what we're trying to maximize our actual result product, and max value is going to also be initialized to 0. And rather, I'll name this max prefix. Sorry. Again, so max prefix is simply the maximum value that we encounter so far. Max value is actually our output. That's going to be the actual maximum triplet value that we find throughout all iterations. And maximum difference is the maximum difference of nums I minus nums j that we multiply with nums k, right? Or again, nums k can correspond to max prefix. So let's go ahead and get into the actual iteration of the input array nums here. So for basically every single number or num in the input array nums, simply looping through each element exactly once in the input array, we'll update our three variables accordingly. So the max value is either going to be the maximum of either itself. We don't want to make it, of course, smaller. So if this is still the largest value that we've seen so far, let's just keep it like itself. Or it's going to be the maximum difference that we found being multiplied by our maximum k value, or in other words, our current k value, which is going to be the current value num. Right here, again, we're basically just for each num calculating the potential triplet value by multiplying the maximum difference, the maximum nums I minus nums j value, to the current element num. Right? That's going to be basically the maximum of its current value and this new triplet calculated value. Right? That's basically how we actually calculate the maximum value output for each iteration for each current element num with the maximum difference that we found so far for the previous two indices. Now we also want to update our maximum difference. This is the maximum difference between our two nums I minus nums j values. It's going to be the maximum of either itself. Again, it could be because we don't want to make it smaller by any means. And also the maximum prefix, that's basically just the maximum value we found so far minus num. Because again, we always want to subtract the smallest amount from the largest amount to get the smallest result, or the largest difference. Because again, anything small being subtracted from anything big is going to give us a larger and larger amount, which is effectively what we want to maximize, because anything large being multiplied to anything large would give us a larger value. And so we want to maximize the difference that we have between these two elements to give us the maximum value, because again, it's being multiplied. That difference is being multiplied by our maximum nums k value, where again, we're maximizing nums k in the max prefix variable. Here again, the max difference is going to ensure that we always hold the maximum difference that we encounter so far by comparing its current value with the difference between the maximum prefix or maximum value we found so far and the current element num. Right? Once we actually update that, the final thing that we want to update is our maximum prefix. This is nothing but the largest value that we've seen so far, our largest k value. That's going to be the maximum of either itself, because again, we don't want to make it smaller by any means, or you guessed it, just the current element itself, num. This num current element is basically just a new potential k value if it's larger than the maximum value that we've seen beforehand, or the maximum element that we've seen before. Right? We always want the maximum prefix to be the maximum value from the start up until the current index, and that we use it to update our other two variables accordingly in each iteration of the input array. And effectively, we simply want to return our maximum value. More specifically, this is the maximum triplet value among all the indices I, j, and k that maximize the value, because it would actually store that eventual result after we actually process all the elements. So unless I made any syntax errors here, there should be accepted and there should be a valid solution. And as you can see, this really is just about as efficient as you can get it to be. So again, on a high-level rundown, how are we solving this problem? Well, we're keeping track of three different variables or integers here. We're basically just keeping track of the maximum value that we found so far, the actual maximum triplet value that we've seen across all kind of triplets of elements or indices, and the actual maximum difference that we want to maximize to multiply with the maximum value that we've seen so far at nums at k, right? So again, we're computing the maximum value of the expression nums I minus nums j times nums k for all valid triplets I, j, and k, whereas, of course, again, less than j, which is less than k. We're always maintaining and updating our maximum prefix and maximum difference during that single iteration or pass of the array, and we always kind of ensure that we're going to have a linear time solution. Why? Because we're just iterating through each potential maximum element num exactly once, and updating the maximum value that we found so far and maximum prefix, the maximum triplet value that we found so far if this num contributes better, and the maximum difference that we're trying to maximize in the nums I minus nums j value, right? So for the runtime complexity here, this is actually, again, linear. It's just a big O of n. Why? Because we're iterating through each potential maximum element exactly once, or each element in the input array exactly once, right? It's just a single iteration, single pass, or singular for loop solution. And technically, within each for loop or within each iteration, we're performing some constant time operations like adding or maximizing, and that's all fine. That's still big O of 1. That's not going to affect our runtime complexity. So our overall runtime complexity is big O of n, or linear solution. And for our memory or space complexity, it's actually going to be a constant time solution. It's going to be big O of 1. Why? Because we're not actually using any auxiliary memory or any extra data structures. We're only using a few integers like maximum prefix, maximum difference, and maximum value, which are not going to kind of scale linearly with the input size, regardless of the input size. So we're going to use a fixed kind of amount of space, making it constant, and that's why we have a constant or big O of 1 memory or space complexity. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.